Hello, my name is Colin Foulke, and I'm here to share with you my method for making shells. If you haven't seen my presentation from Hangout USA 2016, I'd recommend watching it. It'll give you an overview of the method along with how I developed it. I call this method pressure forming, and it's a category of hydroforming. Unlike traditional hydroforming, which is an industrial technique that uses big machinery and pressurized bladders, this method can be done for a fraction of the cost, and you can do it yourself. In the following video, I will walk you through how this method works and how you can construct your own machine. Please keep in mind that this method can be dangerous, and it's extremely important that all safety measures and precautions are taken. Come on, let's get started. The first thing I'm going to do is walk you through the plumbing for this system. The plumbing here is working from the right of the screen to the left of the screen in terms of flow. So on the right is just your general garden hose, and that is what you're going to be plugging into the pressure washer. I found it convenient to add a on-off valve at the connection point from the hose to the pressure washer. My garden hose hookup was outside of my shop, so it was annoying to have to walk in and out of the shop to turn the water on. So I just turn the water on, and then I have this optional valve here where I can turn the water on and off right at the pressure washer, which is inside my shop. From there, there's this little converter. It's a M22 converter, M-22 converter, and it allows you to eliminate the spray gun that comes with these pressure washers. And it allows you just to plug in a standard 3/8 hose fitting into it. So it's the M22 to 3/8 fitting, and that connects right at the pressure washer. Now from here, we're going to be all in pressurized water, so we're going to want high pressure hoses. So a high pressure hose then goes, and this is the center of the screen here is the system that I use to control the amount of pressure that goes into the system. So the first thing we run into is a needle valve. There's a T, and it goes to a needle valve. And the needle valve is a really sensitive valve that allows you to slowly open or close it. And what that does is it allows you to slowly increase or decrease the amount of pressure into the system. On the end of that, at the top of the center of the screen, I have another on-off valve. Again, this is kind of more for convenience, but it allows me to close that valve without having to adjust any settings on the needle valve. Especially when I'm going to purge the systems, but I'll talk about that later. So that's that optional, but I like having it. And then so after the needle valve, there's another T, and this is where you put your manometer or your pressure gauge. And this is downstream from the needle valve. So this is what shows you how much pressure is actually going into the plates. So from the manometer, we hit another high pressure hose, and then from there, you're looking to then plug it into your plate. So again, there's a couple ways you can do this. I have a little right angle there, which just made it a little bit smoother for the transition from the hose into the plate. Now, where this right elbow is you're going to have to tap that hole. And if you've never tapped a hole, I recommend practicing. So this hole is tapped, and you'll see it in the drawings. This hole is tapped for again for 3/8 connection with the hose. So again, then at the outlet where it's labeled purge valve, there's another on-off valve there, and when that valve is open, the system can't get pressurized. As soon as you close that valve, that's when you start adding pressure to the system. And then from there, you don't need a high pressure hose. You can have a low pressure hose, and I'll show you in the next video that part of my hose that comes out of the system, I have a little clear section so I can see when I'm purging it. So to review, from the right of the screen, we have where you turn the hose on and off, and then you have where the garden hose plugs into the pressure washer. I have an extra valve there as an option, so I don't have to go back to the start of the hose. I can just turn the water on or off there. Then you have the pressure washer. Then you have the M22 converter there to the 3/8 hose with high pressure hose, and then you connect to a T. Off of that T is a needle valve, which is a sensitive valve that allows you to increase or decrease the pressure. I have an optional on-off valve after that, so I don't have to change any settings on my needle valve, and it helps to purge the system quicker. Following the needle valve is a second T, where it tees off to your manometer or your pressure gauge. And again, this order is important because you want the manometer downstream from the needle valve, because that's showing how much you're increasing or decreasing the pressure. From the T from the manometer, you have another high pressure hose that then plugs into your plate. I have put a right angle there. because I think that it makes it a little bit smoother for how the hose hangs. And then you have a 3/8 hole that's been tapped into the plate to connect. You have another 3/8 hole that has been tapped to have the outlet. Here you have a valve, the purge valve, and again, this is not an optional valve, you must have this one, and that is where if it's open, you are just purging the system, you don't have any pressure, but as soon as you close that valve, that is when you start to pressurize the system. So that is the plumbing, again, from the right to the left of the screen in terms of flow. One part that's important to note is that the inner edge of the ring needs to be softened, and you can see this in the drawing, and this can be done either mechanically, or I did mine manually, meaning I did it by hand. All I ended up doing was taking a file to the edge and then slowly softening it that way, and then polishing it with lighter and lighter grit sandpaper. So you can see it here that I have a straight edge up against it, and you can show that it's just round a little bit. The idea being that some of the blank metal is going to get pulled over this edge. If this edge isn't softened, there's a really good chance that the blank will shear right here. So again, it's just important that the inner edge of the ring that the metal is going to be forming over is softened. The gasket is one of the most critical components to get this system to work. The amount of pressure that's going into this system is significant, and this little gasket, which you can see here in the drawing, has a inner diameter of 21 inches, or whatever your ring size is, and an outer diameter of 22 inches, which means it's a 1/2 inch wide, and it's of 1/8 inch thick neoprene rubber. Essentially, that's it. So this gasket is glued to the main plate, to the top plate, and it sits in between the top plate and the metal that you're trying to form your blank. And when the pressure comes in, when everything's bolted together, which we'll go over next, it keeps the pressure in and it doesn't allow the water to escape. And this was one of the most frustrating parts and things to get right. So this is the solution that worked for me. It was 1/8 inch thick neoprene and of these dimensions. I should say that I used a 1/4 inch, which was very successful, but it caused some other issues, so I eventually optimized the gasket down to 1/8 of an inch thick. And here it is glued to the plate, so this is what it looks like in real life. It's not super fancy, but it's very effective, and again, this is one of the most critical components because keeping the pressure in is the name of the game when you're trying to form with water pressure. Having a switch system is really critical to ensuring that your results are repeatable. What I mean by this is that your shells are going to be the same depth every time and the exact depth that you want. This is a really simple switch system that I developed. What you see here on screen is to the very left there's a big plug, and that's the pressure washer. So the power supply from the pressure washer is plugged into a power strip or a multi-plug. And most of those power strips have an on-off button that will click on or click off, and usually when they're on, they're illuminated red, and that's what you see here in the picture. So the idea is that the shell that's forming, as it's forming, it comes down and it presses the pin into that button, and that button gets flipped off, and then the power to the pressure washer is off and the system turns itself off. It might take a few shells to get that pin calibrated, and what I mean by that is that I had originally shot to have this pin be 4.5 inches of depth, so that when the system turned off, the resulting shell would be 4.5 inches deep. I had it set to 4.5 inches. I ran the first shell, and something I didn't expect is once the pressure was taken off of the shell, it sprung back, meaning it slightly reduced in its stretch and depth. And so I think I came in at like 4 3/8, or maybe even a little bit closer to 4.5. So I simply took off that length off the pin, ran the next shell, and achieved the depth that I wanted. once I had one pin calibrated, meaning that I knew that pin would yield a shell of 4.5 inches of depth, then I could make any pin of any length and just adjust accordingly to make any shell of any depth that I wanted. So again, the switch system here means that you no longer control when the machine turns itself off, meaning that you're removing any potential human error, and that the shell turns the machine off when you reach its desired depth. Loading a blank and bolting it together is probably the physically hardest part of this whole process and maybe the most tedious. One thing that I have done that has helped with this process is I have drawn out this 24-hole star pattern, and we use a star pattern kind of like how you would put a car tire on. Is you want to slowly tighten the bolts so the pressure across all of the different bolts is even. So you'll see down around 6 o'clock there is hole number 1, and then up around 12 o'clock is hole number 2, and then over around 9 o'clock is hole number 3, and around 3 o'clock is hole number 4. Now if we go back to the first hole and then we skip a bolt over, you'll see that's where number 5 is. So from number 4 to number 5, that's where you start, and then you'll see 5 across is 6, and then over in the corner there is 7, and down is 8, and then so on and so forth. So again, I start with number 1 and then go to number 2, and then from number 2 over to number 3, and from 3 over to number 4, and so on. Now it should be said that those first 4 that I do, I tighten them very lightly. The idea being that if I was to tighten the bolt in hole number 1 really tight, the plates would separate a little bit over by hole number 2, and that's exactly what you don't want to happen. So the first 4 I tighten fairly lightly, and I'll come back and tighten them again, which I'll show you next, but it's important to get those first 4 in and to have the tension on those fairly even so the plates are still resting together fairly evenly. So once I've done all 24 in this star pattern, the next pattern I follow looks like this. I'm back to hole number 1 after 24, and from hole 1 I then go over to hole number 5, and then I double back to number 13 and then skip to 17, and then now I'm back to 5 and I skip to 9. So I kind of just leapfrog, and I do this all the way around the ring until I'm back to hole number 1, and then from there I go from hole 1 to hole 13, and then hole 13 to hole 5. The idea being that I just tighten them then in order all the way around. This has been the system that I use that has led to the most success. It also helps. I actually have these numbers written out on my plate, so I have a visual marker, and I can kind of just count along, and it keeps me going in an order that is right to put the plates together. So again, this is a 24 star pattern like you would put a tire on a car, and that's it. Purging the air out of the system is without a doubt the most important step when you're getting ready to run a shell. So I have the plumbing drawing again, and you'll see that I've relabeled it with what valves are open and closed. So this is to purge the system, meaning get any of the bubbles out. Trapped air in the system will compress. Air is compressible where water is not. So it's really important, and it's a safety concern to get all that air out. So the way that I do it is starting over on the right of the screen. I now have the hose on. That valve is open. I now have opened the valve that goes into the pressure washer. Again, this is just more for convenience because it's located in my shop and not outside of my shop. The pressure washer is currently off. And then continuing down on top of the needle valve, that valve is currently closed. I'll open it later, but right now I want all the water going into the system. I don't need to bleed off any pressure. So from there it goes straight into the plate, and again the plates are put together and bolted together, so the water should then just come out of the outlet where it says purge valve, and again that is open because I want to purge all of the air out. And when I say purge air, I mean get all of the bubbles, any air bubbles out of the system. And this can take a few minutes. When I run the machine for the first time in the morning, it takes quite a bit longer because all the hoses, the entire system has to purge its air. So this is what it looks like when I first start. So I have a clear section of hose on the end of my outlet hose, so I can just see visually, and it looks something like this. So you can see that it's kind of a foamy white, and there's still lots of bubbles in it. And if I continue to let it run, I'm going to now fast forward a bit, it'll start to look something like this. So now you can see that it's running clear. I think a few minutes have progressed in this clip. And so once I see something like this, then I know that I have purged the system and I am good to go. So again, you want to purge all the air out of the system because you don't want any air bubbles being caught when you start to pressurize, because air is compressible and that can be a safety concern. So going back to this drawing, we open the valve to the hose so that we turn the water on. We let the water then go through the pressure washer. We don't need to bleed any pressure off right now, so the needle valve is closed, and then it just goes into the plate, out of the plate, and then we watch it until we have purged all the air. And that is how we purge the system. We are now ready to form a shell. We have loaded a blank, we have closed the machine and bolted everything together, following a careful star pattern to make sure everything's under even tension. We then have purged the system of air, which again is one of the most important steps for safety. And so now that we're purged, we have to set the system to accept pressure. So right now this is where the plumbing is. You can see all the way on the left the purge valve is currently open. So the first thing we're going to do is we're going to close the purge valve. Then we're going to go back into the system, and the valve that's closed above the needle valve, we are now going to open that. And at the same time, we're going to set the needle valve to the starting position, this meaning that the valve is fairly open so that the pressure doesn't immediately run into the system, right? We want to be in control, so having that needle valve set and open a fair bit will allow you to slowly walk in the pressure. And now we're ready. The last thing to do is to turn on the pressure washer. So now the pressure washer is on and we are ready to go. So I have just turned on the pressure washer. In the bottom right of the screen, you're going to see the pressure gauge along with the needle valve, which I will slowly close. So it can be a bit hard to tell, but we're about 50 psi right now. The numbers in red are PSI, the numbers in black are bar. So the blank that I'm forming here, I have drawn a grid line on, ½ inch by ½ inch grid line, so it'll be a little bit easier to see it form. Now below the forming shell is the switch system that I have set up. So the forming shell is going to come down, it's going to hit that pin, and the pin will turn the pressure washer off. So we've just hit 100 PSI. And with my starting position on the needle valve, that means that I won't touch the needle valve. It'll ramp up till about 150 psi before I ever really touch the needle valve. So there's not a lot to see at this point. The incoming shell that's forming, from the user's point of view, you really can't see it yet. It hasn't cleared the thickness of the plates. So you can see I'm coming up on 150 psi now. Okay, so now I'm reaching in, and this is the first time that I'm going to slowly close the needle valve. So if you can see on the needle valve, it's actually numbered, and below it are different color rings. So my starting position is 0 on the black ring, and now I am slowly closing it. So I went from 0 down to 9, and that was just the first turn. And so we're reaching, we're about 190 psi right now. My pressure gauge goes up to 500 psi. And so we're coming up on 200 psi. And at this point, from the user point of view, we can probably see the shell now. It has cleared the rings, and meaning it's probably about 2 inches of depth. So I've now crossed over 200 psi. And usually what I do is I let the pressure settle, meaning once it stops increasing, I will then close the needle valve another numbered turn. So I'll go from 9 down to number 8. So I'm watching the pressure gauge, I'm keeping an eye on the shell, I'm looking around to make sure nothing's leaking. And so we're at coming up on 200 and say 30 or 40 psi. And you'll notice I still haven't touched the needle valve yet. It's still going. And while I'm doing this, I should say that I'm also watching a timer. I have a timer on my phone that I hit start on. Using time as a gauge of how fast things are going can be really helpful. So I'm both watching the pressure and I'm watching the time and kind of how fast things are forming. I have a general timeline that I like to follow. So here we are coming up on 250 psi. You can see that the shell is fairly well formed now. We're probably about 2 inches from hitting the pin, which will hit the button and turn off the pressure washer. And now I'm reaching in and I'm going to go ahead and close the needle valve from 9 down to 8. And again, we should see the pressure then continue to increase. It might increase in rate a little bit too. Again, I don't want to rush the pressure in too much. In my pressure washer, it tends to pulse, meaning that it increases and decreases in pressure as it's increasing. And I think of that as a negative thing. So by controlling the pressure going in, I control the rate that it goes in. And you'll see that the needle does bounce a bit, but it really is no more than, say, 5 psi, which I'm very comfortable with. A pulse would be maybe 20 or 30 psi. So I now have closed it from 8 down to 7. And we're coming right up on 300 psi. And you can see that the shell is starting to slow down in speed, in forming speed. And we're probably about an inch off of the pin right now. I should say that the shell that is being formed right here will have a final depth of 5 inches, and that's a little over 12.5 centimeters. This is as deep as I form. Alright, so I'm increasing the pressure again, now from 7 down to 6. And we're still hovering around 300 psi. I know that the shells that I form, this is 18 gauge 1008 steel. I know that they'll finish forming around 350 psi. So I know that I still have a little ways to go. But crossing into 300 tells me that I'm getting pretty close to my final finishing pressure. Again, I'm keeping an eye on the time, and also now I'm really visually watching the shell. I have a really good view of it now, and I know exactly how far it is from being done. Okay, so hovering around, looks like 330 psi. See, the shell is still forming, so I'm going to go ahead and close it. Looks like it was at black 5, and now I'm closing down towards black 4. You can see the shell start to form again. And we're getting really close to the pin. Now again, the pin is going to hit the switch on a power strip or a multi-plug, and the pressure washer is plugged into that. It's wrapped under plastic just in case water gets on it. But the pressure washer is plugged into that, so it's just going to switch off power to the pressure washer. Something I have to be careful of is that as soon as it turns the power off, the pressure washer will turn off, and it will decrease in pressure, and the forming shell will spring back, and then it'll come off the button and the pressure washer will turn back on. You'll hear me actually miss it. It'll kick on again, but then I manually turn off the pressure washer once the shell is formed. There it goes, kick back on, and we're done. So now what's happening is the system is purging itself of pressure. It's going back through the bleed-off hose and out of the system. And so I just let it sit there and decrease. I have also switched off the hose, the valve that goes into the pressure washer. I have turned that valve off. You can see we're down almost to 0 pressure now, 50 psi. We'll wait a little bit longer and let the last bit of pressure go, and it looks like there it is. So we're now down to 0 pressure, so the system no longer has pressure. So we have a shell that's formed, it has turned itself off, it's at 5 inches deep, and we're done. So this is maybe my favorite part. I have unbolted everything. In no order, I just go around in a circle. I've lifted the top plate off, and I am left with a dish of water, and here I am. I'm just going to siphon it out. One thing that can happen is that the shell that's formed can be somewhat suctioned to the top plate. Sometimes just opening it up a bit and letting the weight of the water pull it down will help. So now I'm going to siphon, and we're just going to go ahead and fast forward. So I've got just about all the water out. Okay, so done with the siphon. Now I'm going to take this shell and pick it up and just dump out that leftover water. I always wear gloves. It's just easy to get cut with working with that sheet steel. And I'm going to flip it over. I'm going to put the shell back on the plate, this time shell side up, and there it is. So this is what you just saw form. The grid line really kind of helps show the stretch distribution. And you can see that there's some distortion on the holes there from the bolts. It's not too bad. And so again, this is a 5-inch deep shell, or about a little over 12.5 centimeters deep. And so what I'm showing you now is this is the pull mark, or this is the metal that got pulled over the edge. Remember how we said it was really important to have that edge softened? So this is the result, is you get this little bit of a pull. And usually I use grease on the ring, and it helps soften that edge, but for this example I wanted to not have grease on. All that's left to do is just to trim off the excess and leave a flange. If you choose to pursue this method, I will say again that this process can be dangerous, so please take all safety precautions. Thank you for watching, and good luck.